Hi and welcome to the video training of comprehensions in Elixir. In Elixir, it is common to loop over an enumerable, often filtering out some results and mapping values into another list. Comprehensions are syntactic sugar for such constructs. They group those common tasks into the for special form. For example, we can map a list of integers into their squared values. Okay, let's go to the console, enter the interactive mode of Elixir, and let's create a for loop less than equal to 0, 2, 3, 4. Okay, do n multiply by n, and we get 1, 4, 9 and 16. So what we did is we looped through each element of the list and multiply by its equivalent number. So we get the output as 1, 4, 9, 16. A comprehension is made of three parts: generators, filters and collectables. Okay, what are generators and filters? In the expression above, n points to the list 1, 2, 3, 4 is the generator. It is literally generating values to be used in the comprehension. Any enumerable can be passed on the right hand side of the generator expression. For n, and you can give a range 1 dot dot 4 and do the same thing. So you can simply do for n, and you can pass the range here 1 dot dot 3 and we get 149, or 1 to 10 and you get the range. Okay, generator expressions also support pattern matching on their left hand side. All non-matching patterns are ignored. Imagine that instead of a range we have a keyword list where the key is the atom, good or bad, and we only want to compute the square of the good values. Okay, let's create a list: good 1, good 2, bad 3, good 4. So that's what we have in the values as a list. Okay, for good n, values do n multiply by n. So we get 1, 4 and 16. So basically what is happening here is we are fetching values from keyword good, and the first value is 1, so we got 1. The second is 2, we got 4. 2 multiplied by 2 is 4, and then we got the fourth one, that is 4 multiplied by 4, 16. And it only picked the values with the good keyword. The third element had the key bad, that's why it didn't pick that up. Alternatively to pattern matching, filters can be used to select some particular elements. For example, we can select the multiples of 3 and discard all others. So if I can write multiple of 3 and equal function n rem n comma 3 equals 0 end. Okay, now I have got the function, and let's call this function, give the range multiple of 3 and multiply by n, and we got 0 and 9. Comprehensions discard all elements for which the filter expression returns false or nil. All other values are selected. Comprehensions generally provide a much more concise representation than using the equivalent functions from the enum and stream modules. Furthermore, comprehensions are also multiple generators and filters to be given. Here is an example that receives a list of directories and gets the size of each file in those directories. So we can create a directory here, list of directories, and mine is home Osman, and the other one we can give home Osman projects, and that's our list. Now we can loop through the directories list, directories, and file dot is not directory. This statement is checking if the file is not a directory. Okay, so it is ls explanation mark and directory. Okay, and then we have the path dot join directory and file dot regular path do and file dot stat not equal path dot size. End of the function. Okay, it has returned the number of files within these directories. It gets the size of each file in those directories. So basically our loop iterated through these two directories, home Osman and home Osman projects, and it gathered the size of each file in these directories. Multiple generators can also be used to calculate the Cartesian product of two lists. Okay, for I assign to a list A, B, C, J 1, 2 do I, J, and that's we calculated the Cartesian products of two lists. Finally, keep in mind that variable assignments inside the comprehension but in the generators, filters, or inside the block are not reflected outside of the comprehension. Okay, let's look at BitString generators. BitString generators are also supported and are very useful when you need to comprehend over BitString streams. The example below receives a list of pixels from a binary with their respective red, green, and blue values and converts them into tuples of 3 elements each. So let's define pixels and let's define some values. Okay, and now we are going to go through the RGB colors, RGB, and here we refer to the pixels that we defined above, comma do colon R comma G comma B. Okay, and there you go, we got the RGB combinations within 4 tuples of a list. A BitString generator can be mixed with regular enumerable generators and supports filters as well. Let's look at the into option. In the examples above, all the comprehensions returned list as their result. However, the result of a comprehension can be inserted into different data structures by passing the into option to the comprehension. For example, a BitString generator can be used with the into option in order to easily remove all spaces in a string. So, assign it to string hello world. You see we have 1, 2 and 3 spaces in the hello world string, and c not equal to \s into do colon c greater than, and we got the hello world here. The variable c, we got an error first. It says variable c not is unused. If the variable is not meant to be used, prefix it with an underscore. Okay, we need to give a space after c and we get our result, a string without any spaces. Sets, maps and other dictionaries can also be given to the into option in general. Into accepts any structure that implements the collectable protocol. A common use case of into can be transforming values in a map. So let's say we have a key value tuple assigned to string A, value 1, we have string 2, B, 2 into empty tuple do key val multiply by val. Okay, we got the result. Let's make another example using streams. Since the IO module provides streams that are both enumerables and collectables, an echo terminal that echoes back the uppercase version of whatever is typed can be implemented using comprehensions. So let's say we can define a variable stream and assign it io.stream value with standard input, output and line. Okay, for line stream into stream do string dot uppercase line then equal to \n end. Okay, now we have entered into an output mode, input output mode by starting the IO stream. Now type any string into the terminal and you will see that the same value will be printed in uppercase. Unfortunately, this example also got your IEX shell stuck in the comprehension. So you will need to hit Ctrl C twice to get out of it. So let's see this in action. TechWeber. Okay, I typed in TechWeber and it gave me all in uppercase. Let's type YouTube and I get the YouTube in uppercase. So whatever you type here, you will get the result in uppercase. Okay, now we are out of the interactive mode. If you liked this video, don't forget to subscribe to my channel. If you need any help, feel free to contact me. My email address is umehmood@gmail.com. You can contact me on LinkedIn as well. This is my LinkedIn page URL, and my Twitter handle is Usman_TechWeber. So you can contact me there as well. So see you next time with a new topic in Elixir.